Hello, Antonio. The webinar has started.
Hello, everyone. We will wait 1 more minute for the people to have time to connect. Okay, we are on time, so we will start. By the way, the webinar will be recorded, so everyone can read or see the webinar later. Hello, everyone. Welcome and thank you for joining this session dedicated to stamping die process, even if it is Friday evening, I know, but what better way to kick off the weekend than with a deep dive into Dassault System stamping die solution, from design to manufacturing, of course. My name is Antonio SCARCELLI, and I am delighted to present this 1 hour session for you and with you. First, we will take a look at the stamping die process, and then we will focus on the stamping die face design application with a demonstration of CATIA die face design. You can ask any question in the Q&A section of this webinar. You will find the icon very easily. I will answer to your question before the end of this session. So let's start. Concerning the stamping process, when we speak with our customers, they define roughly the process, and you can see it on the left here, where they want to be able to design the product. So that means the part that we have to stamp. They want to validate and certify the part. They want to design the process. They want to design the tools, all embedded in a simple and a clear environment. They want, of course, as we have explained previously, from design to manufacturing, to be able to manage all their data. They want to, of course, reduce the time to market and the cost. This is the main topic that came every time. And they want to improve their current process that they have today. So what are our drivers in order, coming from the challenges of the customer, in order to propose some solution in the system? We are targeting to be able to very quickly be able to predict the cost. And for that, first, we need to analyze the manufacturability of the part that we have received. So how to propose to a customer a capability, easy capability, to be able to check the feasibility of the part and to be able to very quickly have an idea of the cost. After, what we want to do is to improve the process capabilities in order to have a product of very good quality, to have output of high quality, for example, to be able to use this output for any simulation, for any manufacturing. For example, if I want to mill the output from my solution, it should be possible with the quality of the surface that we can provide. Reduce time to market and cost. This is one of the main targets that were expressed by our customers. Something also that is very important, because we know that in this process, in general, the customer has to face a lot of design change. So we need to put in place a methodology in order to be very, very flexible for the design change. And the last one of our drivers is that we are driven by customer request, by customer specification. We don't want to develop a function that the customer will not need, will not use. So more and more cars are produced. So we need more and more sheet metal part to for body in white, for the external shape of the car to be produced. And one of these steps is the die phase design. How I will design the process to produce my dedicated part, and how I will be able to define the different elements, surface, curves, direction of stamping, direction for the cam, to give this information to the guy that will do the die design, to the guy that will do the die manufacturing, the die machining, and so on. This is a critical phase. This task of die phase design is very critical because it helps the user to get the information about the price, the cost, and to get the information to be delivered to the other people that are involved in the process. So it is why we decided to develop a specific application that we call die phase design. We have two solutions today. One is based on CATIA V5, and the other one is based on 3D experience. Today, we will concentrate, we will focus on the 3D experience one. But just one word about the CATIA design one. The solution is called TDF. It's an application that is called the TDF. And in 3D experience, the solution is, the name of the role is STDI. And it contains the following application. We will speak a little bit more about it. Some words about V5 and 3D experience at the same level of product. Okay, for example, in 25X in 3D experience and V5-6R25 in V5, you have the same level of capability with the same level of function, parameters, and so on, options, and so on. Okay, except that since 25 in 3D experience, you have additional capability based on simulation, for example, for the quick formability analysis that is not available in 3D experience. Otherwise, up to now, you have the same level of capability between the applications. Okay, so what is the aim of our stamping die solution? Is to deliver capability to automate the workflow for a stamping expert, for a guy that is very expert on designing stamping die, on designing die phase, but not being a CAE expert. The application is offering capability to manage the data with some feedback from the product, feedback coming from analysis, feedback coming from simulation that is embedded inside a mechanical function for us as mechanical engineer that we are not CAE expert. After, with the help of the platform, what we are offering is the digital continuity from the design to the manufacturing. And to do our job, in fact, we will work on STDI role. We will work mainly with die phase design. That is the application that will be demonstrated later. But we will have also the help of the engineering IP control, for example, for sharing information outside without disclosing our IP. We will have smart mechanical components that will help us to design the different toolings in order to, for each operation, we need a tooling. So in order to instantiate components, we will have also digital shape preparation, and virtual to real shape morphing in order to take into account the spring back when it is needed on the different operations. Okay, so some words about STDI. So this is the process that I will explain a little bit more in detail later. As we said, we want to increase the productivity. And this is something that is feedback from our customers. Okay, so there are some numbers that I can give to you. This is coming from the experience of some customers. Okay, some customers, they were able to reduce dramatically their time in the global process. They are compared of what they are doing today with the tool they have in V5 and with additional product, and what they are able to do today with a 3D experience. Okay, and one important thing also is very important, because there is a specific function. As I told you, this is one of our main driver. There is a specific function, a specific capability to help us to manage the design change. And based on that, they were able to reduce by 40% their time and their cost for any design change. So this is a very important. What you remember, I said that we want to offer a global tool to design the process. So you see, you have the tool, you have the design, the product design, you have the design of the process, the design of the tooling, and so on. But all that one, all what you are doing in this area, that is the area of CATIA, you need to simulate it. And this is the area of SIMULIA. And you see there is an intersection here where in some function, you have access to the capability and the power of SIMULIA embedded inside some CATIA functions. And after here, there are some capability that are pure simulation, where you need a license from simulation. So that means we are working completely in a MODSIM approach, where simulation and design are very close, embedded, and of course communicating through data, through parameters, through result of simulation, and where some dedicated function contains some abacus capability in order to very quickly, at the level of the mechanical user, not being a CAE expert, to give him some result and to be able to continue his work. Okay, so with this environment, we dramatically reduce the time of communication between the what are doing today our customers, between the CAE design and the simulation, where I have to submit my my design to the simulation, and I need to wait for the result. Here we are completely embedded and completely communicating. So this is the full process that we are able to cover with our roles, functions, and so on. First one, we are able to design the part design. So this is nothing new. We are doing that since many years with GSD and so on and so on. Any application to define the shape of your car, to define the shape of any part of your car. After that, we will go in the step of the die phase design, where we will have a deep dive later, where you will define the different operations that you need to produce your part, and where you will define the detail of for each operation and be able to transfer it to the manufacturing, to the guy doing the control, to the guy doing the marketing, the sales, or whatever. Okay. In parallel, if you need the die compensation, we have a tool to do the die compensation. This is existing since V5, but in 3D experience, they are available, and you can import the result of your die compensation into your tooling design. After that, for each operation that you have in the succession of the tools that you need for producing your part, for the draw die, for the restrike, for the cutting die, for the piercing die, for the trimming, and so on, and the bending one, you will have to design for each of them one tool. So it is a die shoot, there are blank holder, there are upper die, sample effect, double effect, and so on and so on. So this is also some activity that we can conduct with the help of assembly design, of part design, of GSD, of knowledgeware, and whatever. Okay. After that, you need to simulate your tooling one by one and maybe your line. So for that, we have the virtual reality simulation. Many customers are using the virtual reality. You have some specific tool to simulate, to analyze the kinematic of your stamping die. And you have some specific tool thanks to Delmia brand for simulation of your line of the production. Once you have qualified good your stamping die, you have to produce your die. So for that, we have a direct link from what we have designed here from, you remember the input are coming from the die face, what we are designing in the tooling, you will be able to mill each part of your tooling to prepare the casting, to prepare the milling, to make the assembly and so on. And at the end, you will be able to go in production and to get your final part. All of that is managed through the platform. Remember, the platform is a platform of collaboration. So that means all the people involved in this process will collaborate. As soon as one guy or one stakeholder is doing a modification or is enriching the data with some additional information, this modification is immediately available for all the people, and everyone can take advantage of this modification or take it into account. So now let's have a look at what we propose on the die phase design. With die phase design, the process is very easy. It is divided in two steps. One step is the layout design. So that means very quickly to have an idea of the number of operation, that means the number of tools that I need, and very quickly analyze the different tools in order to get the cost of my part of my tooling and so on. So for that, we start with the geometric analysis. That means I will analyze my part, how I will manage, how I will define my stamping direction. That is something that is very important. After, I will have my formability analysis. So I will analyze my part and to be able to understand if I can easily stamp this part or not, if I will have some problem of reduction of the thickness, of wrinkage, or something like that. So this is a completely MODSIM function, where here you have Abacus that is embedded in this function. After that, you will have a capability based on a wizard to define your process layout in a conceptual way. So we don't need to be very precise. We need just to understand that we will have to provide some cutters, some piercing tool, and so on and so on. How many operations, what are the axis system, what are the cams. This has an impact on my process, of my number of tools, and of course on my cost. In parallel, you will have the possibility to have a global unfold of your part, because we start from a flat sheet metal, so we need to define the minimum size of this sheet metal in order to produce our part. After that, you will have the validation of your process. For each operation, you will do some validation. You will define your structure, and after that, you will have some dedicated function for each operation to define here in detail with very high quality surface, very high quality information. You will define for each operation all what you need: the surface, the trimming lines, the direction of the piercing, and so on and so on. Okay, so this is the global process that we have, and you see here inside, this is the die phase design. So now let's have a look at what I said previously. So first, I start by the process layout. So you see, I have my parts that I receive from the designer of my body in white part. I have my material that is added to my part. And what I do here is a first function. I need to understand where I should have, or I will have some problem, for example, here with based on color, when I will stamp my part. So this is just a step of validation of the part that I have received in order to be able to discuss with the guy that has designed my part and to optimize my part following my process. Okay? So once it is done, we accept the part and so on. We will go on a fantastic function that is called the wizard. This wizard is very important because for the definition of the layout, all what you need to define and to manage is inside this wizard. And the wizard here helps us in populating the tree with all the needed information, with all the parameters, with all the publication, the link and the connection and so on. So you don't need to manage your tree. So this is very helpful because it helps a lot when you will do some modification, because the associativity will be ensured by all what is managed through this wizard. As you can see here, we can manage more than one part. So the management of the parts is up to you, how many parts you want to have as you are used to prepare your stamping. Here, there is also the capability to define the two parts as a symmetrical part. So that means if you define two symmetrical parts, you will have some automatism driven by this symmetry information. Once you have done that, you will position your part at what we call the nesting of the orientation of the part. Here it is the computation of the stamping direction, you see, with a lot of helps in based on color that is very easy to understand to optimize your stamping direction. There are two ways. One is manual one is automatic one. In general, the people are using the manual one because they used to manage in that way. Here, we are doing the positioning of the parts in our process. So the process is a little bit different than the axis where they defined the parts. This is the simulation of the part on the table. If you have the table of your press, and if you want to manage this table, you will be able to import it and to insert it inside your process. Here, just a very nice function in order to define a curve very quickly, in order to use this curve as a kind of pivot to unfold some area of the part that you have to stamp. And here we will take advantage of the symmetry. You see, the blue is the result of the subset that will be unfolded. And you have the symmetry one here. So we will ask to the system to unfold it. Okay, so here it's just a geometrical one. We are in a conceptual design. We don't need to be very accurate. We just need to know that there is this information that I have to manage in my process. To design the cutters, that means what we call the trim steels, very simple sketch. Here as well, we will take advantage of the symmetry. Very simple sketch. And remember, the system is creating the full associativity. So that means when you will make a review, you will be able to come back to your sketch to modify the position of the curves, to add some additional curves if it is needed, to delete some curves if it is needed. Okay, and what you can see as well is that the system has recognized the external boundary and has recognized also all the internal one. Okay, so this is important because it will help us when we will do what we are doing here that is the distribution of the different activity that we have to do in the different operation that we have defined. Of course, this numbering and the number of the operation is some parameters that you are managing through this wizard as well. You have seen we are never outside this wizard. To generate your different operation, what you will do in the different operation, you can either select in the 3D or you can select in this list. Once you select in the 3D, it disappears in the list. When you select in the list and you have the cross-hand light, it will disappear on the 3D. So this is what we call the general hole. So that means that are the internal cutouts that we will do in different operations. Okay. So now, for each operation, we will have some tools to have a very nice visibility of what you have done. So here you see the system has prepared following what you have selected and distributed as prepared the different operation. For example, in OP30, we will do this kind of piercing here, and we will do this kind of trimming that we see here. Okay. In blue, it's the operation that I do in each OP. You can group the tools, because when you have two piercing tools that are very close, maybe you want to have a simple one head for the 2 or 3 tools. Okay, so this is the one that is done here. And after, if you want to move one operation, that means one tool to another OP, it's easy to do because you will select it and you will say, I will distribute to the other one. Here, what we are doing is to grouping the different tool following what we have defined. And after, we will define as well, we will check in the system if we are following all the criteria of validity of our tools, and we will define, if it is needed, some CAM. I will accelerate a little bit because it is always exactly the same function that we are using here. It is the grouping one. Okay, here we do the analysis, and we will see that, for example, here, for this piercing, if I use the Z and the main stamping direction, I will not respect my criteria. Okay, so you can display only the KO, and the system will give you the result. You will be able, okay, you see here, you can accept or not, following your result. Let's go to the one of this cutout here. We need, for example, for this one, to define a CAM. Very easy. The system is providing automatically a solution. You will accept or not, but if you accept, after you validate it, and you see here, we are completely green. So that means here, we can accept this stamping direction with this CAM for this internal cutout. Okay, and the direction, the information that you have a CAM is delivered through a new axis system that is called the CAM axis system. So when you have finished your process, and when you have validated all your operation, okay, if you do any modification, okay, you see the axis of the CAM just in yellow here. When you have finished that, you will create a product. In this product, you will generate for each operation a part. Okay, so it is what we are doing here. We have created a product. We will copy our part on which we have done our layout. So in order to not lose nothing about what we have done in our layout, we will generate a new structure with this specific function of a structure generator. This is done automatically, and it is why the system will generate automatically all the links between the operation. Because at the end, remember, what we would like to do at one moment is to replace my starting part here by a new revision or by a new part. And using this function, you will take advantage of all the connection and the link that are done, created by this function. Okay, so once you have done this one, we have a full structure with different parts for the different OP. And now we can work OP by OP. So that means if I want in my company, I can put 5 guys working on different OPs, or you will open one OP, for example, the first one, the draw die, and you will generate for this draw die all what you need for the draw die. That means the extension. You will first fill the internal cutouts and so on. To doing that, we have a specific function that works globally, again for purpose of associativity, and you will get the function here to generate what we call the extension in order. So you have a different function, very nice function, dedicated for different needs. And you will generate what we call the die face. So for that, we need first to close all the internal cutouts. For that, you have different functions, and you see this one is very good one, because it takes advantage of the different sections, and it will generate some curves that you can manage if you want to have a different result. Okay, we are working a lot with the joins, and we will create the addenda surface. We have a boundary. We will analyze on this boundary what the system can propose, and the system will help us to define through addenda surface capability some curves that are sections that are stored through a sketch with parameters. So you can modify the parameter. You see that at each point you apply a section, you have a kind of handle that you can manipulate. Okay, you can move on the boundary if you want to have a different result. You can copy this one if you have made some modification of the parameters and so on. So there is a lot of flexibility to do that. And based on these different sections, you will be able to generate your addenda surface. So you see, you can add when you want. The system will give you the information if it is good or not, and you will get this kind of result. Of course, our users, they know very well what they want to have, and they will tune either the parameters, either the orientation, either the connection, the tangency, and so on. You can do it through this kind of function. There is another one. There is another function to help us to do that, but you can mix the result from the first one and the second one. That is the boundary analysis. The system will analyze the boundary and automatically will give some solution. Up to you to accept or not, to modify it. It is what we were doing here. But here, the system will deliver one solution. Okay, with some parameterization that you can generate. You have seen in the function there were some parameters. After, you have access as well to the different tool to close the gaps and so on. Once you have done this one, you will generate the join and so on. You will replicate, because as we are working with a symmetric part, we don't need to work on the both. And now we had started with our die phase. Well, now we will need to define the whole of the definition of our punch. So just starting on that way, a sketch, a very simple sketch. We like a lot of very simple things, like a sketch and something. And here you have the parameters for defining the wall with the angle, with the length, with the radius here. At each intersection, the system is generating a fillet, and you can manipulate this value. You can manipulate the value of the wall and the fillets globally, and you can manipulate them locally. So one by one, you will be able to modify it. You will generate the fillets and so on. You will prepare your die face, as you can see here. Okay, and at the end, you will get your die face. On this die face, in general, what are doing our user is that following their experience and some computation of simulation, you need to grip the die face. That means when you will stamp, you need to fix on some area the part, or to force the metal to flow on some direction. For that, we use the draw beads. As you can see, sorry, I will come back a little bit back. Okay, you can see here that you have different sections that are provided in the system based on the experience of our customer as well. With this section are all parameterized and so on. You can see that in blue and green, we are managing the section of the punch and the section of the blank holder with the management of the different radius in order to make the metal when you stamp to be able to move in the right direction. So here you have all these parameters, but you can define also as well different parameters if you need it. Once you have generated your draw bead, you will attach your draw bead to your die face. You will finish here the end of the draw bead with specific functions, and you will get the symmetry and so on. You will define your punch and so on. Okay. Once you have done that one for the first operation, you will go to a different operation, for example, where you need now on this die face here. You remember at the beginning, we have defined a very simple way on a sketch. We have defined different curves that were defining our trim steels. Now what we need, because when we will have done our first draw die, the result will be this one. And now we need to project on this die face here, we need to project the curve in order to get the realistic curve that will be used for the definition of the trim steel. To doing that, we are also as well using a MODSIM application, a dedicated one, in order to project the curve on the die face. And with this capability, in general, what we are doing on some area, we are managing the knock, and we are managing also the overlap between the different tools. Because at the end, if we don't use these methodologies on your part, you will have some extra geometry or some extra sheet metal that is remaining that we don't need. Okay, so you are doing that for each operation and so on. You have also to unfold exactly the area. You remember the blue area that we have defined in the first layout. Now we need to unfold exactly the blue zone on top of the die face, exactly the same that what we are doing for the trim lines. And here as well, we are using a MODSIM function. So when it is done, you have the definition of your full operations. And remember, on these different operations, you will have surfaces, you will have curves, you will have directions, and so on, that are delivered to the people that will design the tooling. And after, you will have the progress of your tool that will be defined in your process. And you see that progressively, the tool, your die face is a cut operation by operation. Okay, so this was to give you an overview of the die face design application that is inside the die face design. Sorry. That was, I want to show you just the result. here I was not very fast to stop the video. That this application is inside the role STDI. And here you see your die phase. You see the different operation. What we are doing here we are cutting this area, so it's no more remaining. Here we are cutting the others, and so on and so on. Okay, so you see the progress of the geometry of your die phase that you have defined step by step, and at the end we will separate the two parts. Okay, so this is the video on that. So just as a summary based on the value, we are in CATIA. So that means you have the full surface quality of the CATIA surface application that are supported. So that means you will be able, for example, to machine this surface. For the updates, we were speaking about that thanks to the methodology and thanks to the application that is driving the parameters and the publications, you will have a design update that will be done in a good way. And there is a specific function when you do a replace of a part to help you to analyze what are the impacts and to be able to modify it. You have the capability in the layout to very quickly analyze the cost of your die. Of course, you will refine it each time you will improve your detailed design. For the productivity, you have seen that we have some functions that are based on MODSIM, on a simulation embedded into the function that helps a lot to avoid some exchange with the simulation guy. And for the digital continuity, we were speaking about that, and it is very important through the platform. So what are some feedback from our customers? So some customers following their current process and with some tests that they have done with the process based on 3D experience, they were able to have a gain of 50% on the global process. The feedback is that also for to be operational, it's not so long, because only with 2 days of training for people, for some user that knows, of course, 3D experience and assembly design, part design. So he is not a newcomer in 3D experience. You have only 2 days and you are very, very quickly operational. The quality of the result of the surface, okay, we saw that. That is a native DS solution. Okay, so we are improving it release after release. And it's existing training, but also the solution is existing in V5 and 3D experience. And what I have not said previously is that if you start in V5 and you want to continue in 3D experience, you will load your product and you will get access to all the features and on edition, because it is exactly the same features. So as a summary, we are covering the full stamping die process. You remember my picture here, with a full associativity thanks to the platform and the dedicated tool. Again, what we think that is very important is the update that is very fast and robust, and you are guided. Okay, and you are integrated with the tooling design based on templates, on smart mechanical component, kinematic and motion. And also we are fully embedded with SIMULIA and Delmia. Okay, so I would say that for today, that's all. We are at your disposal for any other information about die phase design, about what you want, for example, if you want to have a look at the reverse engineering for the computation of the springback, if you want to have a look at how the link is maintained for the machining and so on, we can support you and any customer. Do not hesitate to contact us. I will put you in contact with the specialist of each domain. You have here the link to the replay and so on, so you can check it. Thank you so much for your attention. So now it is time for
The Q&A.
for your questions. Okay.
Yes. Thank you so much, Antonio, for this great presentation. We have a question from Diego Bradors, and it concerns the moment when you were presenting the process generator wizard. And Diego thought that an example with all steps would be fine to see all capabilities. I don't know if you remember, you presented, and I was wondering if we would have a video that we can share with Diego later, perhaps.
Yeah, Diego. We will take your your name and the mail, and we will share with you. And maybe we will have. It's possible to have also an interactive session. Okay, because here we see it, but we have these models. Okay, with this product, and we can go deeply inside the definition of what we have done inside each operation. Yeah. Okay, Diego, we take the point, and we will come back to you.
Good. I have a few little other questions from myself. No,
No, there is another. Yeah,
oh, yes.
there is. Yeah.
You see
Is there any integration with Autoform, and what is our advantages? Very good question. Integration with Autoform, no. Autoform is an independent tool. If you want, what are doing currently our customer is that they use Autoform for doing a lot of activity that you have seen in our demo. Except that when you are doing that in Autoform, you have to transfer your result in CATIA. And as the result is not of the good quality, what you have to do in CATIA is to reshape, for example, your surface with the function of the surface definition in CATIA. Once you have done that, you need to check if the result is good. So you will transfer again your data in Autoform. You will check if the result is good. And if it is not, you have to do the back and forth. So transfer from Autoform to CATIA. The aim of this die face application is to be able to replace Autoform as quickly as we can, because Autoform has more than 40 years of experience working with many customers. I would say all the stamping die makers and all the stamping die companies over the world. So they have a huge experience. They have a very good product where the customers are very happy, except that Autoform is very expensive. So what we are doing is that our advantage are the platform, are the dedicated tools that we are defining based on customer specification. Something that I was not telling you at the beginning is that the specification of this product have been done at the beginning because it was part of a project, a dedicated project with BMW, the German OEM. Okay, and progressively we are also integrating specification from the other customer that we are speaking with since the beginning of the story of die face design. So the product is coming more and more, I would say, rich of function driven by the specification of our customers. So this is a huge advantage. The huge advantage is that also you are in one application, you have some wizard, you will not go outside the application. Okay, you have all the products, all the function, all the capability inside your application. So you don't need to go from one external product to the other one. And also what you are doing here from the layout to the design, to the detail design, you are losing nothing because you will reuse what you have done in the layout. This is not exactly the current process of the customers that are not using this process today. And after, as soon as you have done a modification in your process or in your detailed definition, all the people that are connected to my project through the platform, they are informed and they take advantage of the modifications. I hope it answers your question. We still have some minutes. Are there other questions?
Only a few from myself.
Okay.
It was a little quick for me, but I see you designed the process on a different axis than the part. Is it possible to use that same axis?
Yes. Yes, it is possible. Not currently, but R&D is working on that because we got specification from many customers now. In fact, a lot of customers, they want to have this flexibility. To what we have presented is when we work on with our wizard, the system is defining an axis system. And in fact, it is the 0,0 of your product. Okay, whatever your part is coming from. And in some cases, for some parts, the customer wants to work in a different axis system and mainly on the axis system of definition of the part. So this will come very quickly. Today, it is not, I would say, it is not available in a simple way. So it is why I don't show it and I don't want to use it because it will be part of new capability coming very quickly. Yes, good question. And it's part of the process of our customers. Yes.
Okay.
Thank you.
I have other question, but I think you already answered during the presentation. Let me just check. What happens if I receive a new revision of my design part?
Yeah, I was explaining a little bit. Is that if and we know that in this process, quite every morning, the die designer and the tooling designer are receiving a new revision of the part because they need to start very early in the process to design the die face and the tooling, and they need to put in place what they are doing today in V5. They put in place with a skeleton and so on, with publication parameters, methodology, in order to take into account this many modifications. So thanks to what we said, to the wizard and to the methodology that is put in place to manage the associativity, we can manage any modification. And there is a specific wizard. When you launch it, it's very easy. When you launch it, you say, my old part is this one, my new part is this one, and the system will reconnect all. And it will deliver you a table of all the information that he has to check. And he is able to check them automatically. So if all is okay, he will do it automatically and you are safe. If there is some problem, because sometimes you will have, when you replace a part by a new one, maybe you will have an additional cutout. And this one, the system doesn't know in which operation you want to do this cutout. Maybe there will be a different cutout, a different position, sorry, a different axis system for for the CAM, so you need to validate it. And the system will show you where it needs your support in order to validate the solution that is giving to you. If you are not satisfied, it is like when you are defining the CAM direction, you will do it yourself, you validate, and the system will continue up to the next time when it needs your support to do the job. So it's a very, very fast operation, and it's interesting function, and it's very appreciated by our customers. Yes.
Okay, I think you already answered your question. So I will take the few next minutes just to remind people about the CATIA user community. Is it possible for you, Antonio, to go to the last slide?
Yes.
Please.
This one.
Thank you very much. So, of course, we thank you for your participation in this webinar, but if you would have any other questions coming to your mind later, you can ask these questions to Antonio through the CATIA user community. Here, you can see how to reach it. You can use this QR code or this link, go.3ds.com/CATIA. If you don't have any DS passport yet, you will create one, which is very quick. Then let me share my screen to show where you will arrive. So
I have to stop my sharing.
Oh, yes, please, if possible.
It is done.
Thank you very much. So, do you see my screen?
Yes, I see.
Okay,
By the way.
thanks. So, you see that you will reach the CATIA user community through this link. And here you can, oops, sorry, let me try again. You can reach the post. I hope we can reach the post where the webinar, Antonio's webinar, is displayed. Just one sec. Here, I will go again in the CATIA user community. And sorry, let me try again. CATIA user community, and I wanted to find the place where you can ask another question. So you see here, it was where we promoted this webinar. And here, if you want to ask a new question, you can use this comment section and Antonio will know that he can answer you there. Just one last thing, there is a wiki section in this CATIA user community where you can find all the webinars, for example, for this year, all the replay of CATIA talks and CATIA webinars for engineering or other domain. So that's it now from myself. Once again, thank you very much for attending. Thank you very much, Antonio, for this great presentation. And I think that's it for now. So
Okay.
talk to you
Thank
soon.
you. Thank you, everyone. Do not
Bye-bye.
hesitate to contact. Okay. Bye-bye.
Yes,
Good
great.
weekend. Bye-bye.
Enjoy your weekend. Yes, bye.
You as well. Bye-bye.